They're not.
All right, so today, just so that you guys know, we start the back half of chapter 4. We're going to break this first section into 2 days, just so that you guys know. The first day, what we're going to do is find solutions of polynomials, and then the roots of their functions. So here's what you're going to look at first of all, and it's very similar to what we started with the last chapter, or earlier in one of the other sections. This you've already seen. You've seen ones like this before. What were the directions I asked you to do for this part? Factor it. Right. But here's the catch. Here's the new piece. Now it's going to be equal to 0. So once we factor it, just like we did in the previous sections, we are going to now set each group equal to 0 and find out what x actually is. So the first step in doing these types of problems, make sure it's equal to 0. So that means put everything to one side versus the other. Are we equal to 0? Yes. Second step, factor. So looking at that, is there anything I can take out right away? 2x. And when I do that, I get x squared minus 6x plus 9. Can x squared minus 6x plus 9 factor further? Yeah. What times what gives me x squared? What times what gives me 9 but adds up to be negative 6? Negative 3 and negative 3. Because when I multiply those together, I get a positive 9. But when I add them, I get negative 6. Is everybody okay with the factoring? From here now, this is what you did before for me. Now the next step on this is now set each group equal to 0. This is a group, this is a group, and this is a group. Anything inside parentheses is a group, and anything on the outside is a group. So 2x equals 0, x minus 3 equals 0, x minus 3 equals 0. On the first one, how do I solve for x? What's 0 divided by anything? On the second and third groups, what would I have to do? Add 3, so x equals 3 2 times, right? How many answers would that have been total then? 3. What was the highest exponent? 3. Is that a coincidence? No. Okay, just so that you guys are aware of it, that will show up where we'll have 3 answers because the highest exponent was 3. How many answers could you expect if the highest exponent was 5? 5. How about 6? 6, and so on. This is what you're going to do today for half the assignment, just like this. Okay? So let me give you another one. 5x to the third minus 40x squared plus 80x equals 0. So first and foremost, is it equal to 0? Yeah. So what can I take out to begin with? 5x. If I take out 5x, what do I have left? What's 80 divided by 5? 16? What times what gives me x squared? X and x. What times what gives me 16 but adds up to be negative 8? Negative 4, negative 4. Negative 8, negative 2 would also multiply together to give me 16, but it wouldn't add together to give me negative 8. That would give me negative 10. So be careful with that. Now, what do I do after I've factored it? So I have 5x equals 0, x minus 4 equals 0 twice. On the first group, if I divide by 5, what's 0 divided by 5? 0. And what would I do in the second and third group? Add 4, and what do I get? 4. Twice, right? Now, just so that you guys know, it's not always going to happen where they're the same group twice like that, but it just so happens to be these two do. When that happens, when you have a group that shows up twice, you may hear it referred to as a multiplicity of 2. Or if it showed up 3 times, it'd be a multiplicity of 3. 4 times, multiplicity of 4, and so on. Okay? What do you think so far? Okay? So again, for solving these, step 1, set it equal to 0. That's the first thing that you should always do. Step 2, we factored. And then step 3, set each group equal to 0 and solve. Okay, so those are the 3 steps we're going to take for all the ones for this first half of the chapter, or first half of the section. Are you guys okay with that? Okay, now the only thing that I'm going to do a little bit differently is I'm going to do the same type of thing, except for this time it's going to be called finding zeros rather than finding what x is. And the difference is it's got f of x instead of 0. Okay? It is the same exact thing though. When we want to find a 0, guess what I replace f of x with? 0. Right. So the first thing that I'm going to do is I'm going to take out that f of x. I'm going to put 0 in its place. Somebody's birthday today. That'll go on for another minute or 2. You can? All right, can I take anything out?
Who is that?
Mr. Curtis. Can I take anything out? I'm going to take out a negative 2. The only reason why I'm going to take a negative 2 out is because I want the front to be positive. Okay? Okay? So, when I take a negative 2 out, that changes all the signs. So just so that you guys are aware of that, when you take a negative 2 out, that changes all the signs. Okay? So now, inside the parentheses, factor that. What times what gives me x to the 4th? What times what gives me 16 but adds it to be negative 8? Negative 4 and negative 4? Good. Can that factor further? What times what gives me x squared? What times what gives me negative 4 but adds it to be 0? Negative 2 and plus 2. And the same thing for the back groups, right? What do I do after I factor it? Set them equal to 0. Can negative 2 equal 0? So this part right here, when it says negative 2 equals 0, there's no x there. So guess what? That part really doesn't exist then. What's x minus 2 equals 0? What's x going to equal then? 2. And x plus 2 equals 0. What's it going to equal? Negative 2. And it was actually negative 2 twice and positive 2 twice, right? So how many answers did I have total? 4. I had 2 2's and 2 negative 2's to make 4 total. And what was the highest exponent? 4. Not a coincidence. Okay? The only thing that's different with this as compared to the first 2 that I did for you, it doesn't start out by saying it's equal to 0, so all you do is take the f of x out and put 0 in its place. And then you solve it the same way. Now, if it wanted you to graph that, because that was a function, I know most of the ways that you're going to do it by graphing it is you're just going to stick it in your calculator anyway. However, if I knew a little bit about this a little bit more, 1, 2, make dot, 1, 2, make dot. Why did I make a dot at 2 and negative 2? Because those are the 2 answers that you gave me. Now the other thing that I also know about it is when it shows up twice like that, when it says it's a multiplicity of 2, that has a bounce effect. And what I mean by that is it's going to come down, hit it, and go back up. It's not going to go actually through the 2. It would come down, either come down like this and hit it and bounce back up, or if it comes the other way, it would hit it and go back down, depending on whatever way the graph works. It would also do the same thing at positive 2. When it has a multiplicity of 2 or 4 or 6 or 8, any even multiplicities, it's just going to come up, hit it, and go right back down. That's called a double root. Okay? So, if they ask you to graph it, I know you're just going to stick it in your calculator anyway. Then, let me give you another one. Okay, first thing I'm going to do, I'm going to take the f of x out and put in what? 0. Can I factor anything out to begin with? At x. X squared plus x minus 6. Can the x squared go further? You got to try. If it doesn't, oh well. But if it does, then we got to try it. What times what gives me negative 6 but adds up to be positive 1? Let's start by writing down what times what gives you 6. 3 and 2, 1 and 6. And one of those has to be a positive, one of them has to be a negative. In order to get a positive one, when you add them, what does it have to be, Sierra? Negative 2 and positive 3. When I multiply those, gives me negative 6, but when I add them, gives me positive 1. Now, what do I do for each group? X equals 0. Does that exist then if it's x equals 0? Yes. If it was a number equals 0, not so much. But when it's x equals 0, you bet. X minus 2 equals 0 and x plus 3 equals 0. What numbers do I get out? X equals 2, x equals negative 3. Now again, if they ask you to graph it, guess where it hits? It hits at 0, 2, and negative 3. So if it asked you to graph it, again, I know you're just going to use your graphing calculator. However, it hits here. 1, 2, 3, it hits here. 1, 2, it hits there. Now remember that end behavior stuff that we did a long time ago? What was the highest exponent? 3, right? Is the number positive in front of the 3 or negative? Positive, so I know that it goes down this way and up this way. Then in between there, it probably does something like this. That'd be my guess. But again, that's without a graphing calculator. If you typed it in with your graphing calculator, do you see something that looks like that? Probably. Okay, and some of you guys I know have your calculators out. Some of you don't yet, but that's okay. If it asks you to graph it, sketch a graph, but make sure you put your zeros on there. That's a better way to do it. What do you think? A whole lot of factoring. Okay, so on page 194, 3 to 19 odd.